My name's Abraham. This is Warren.
Here.
And we're presenting Analyzing Cryptocurrency on HBase. I'm going to introduce Warren, who will introduce the business side first, and then I'll go over the technical setup that we did.
How's it going? My name is Warren. I'm the product manager for the XRP team at Ripple. Like Abraham said, we're going to be going over just how we use HBase for finance, forensics, and fraud to kind of analyze some of the market data that we see. You'll notice that this presentation was created in April, so some of the data is a little out of date, and I'll hit on that exactly how out of date. So we just want to basically basic agenda. What is Ripple? How is Ripple, or particularly the digital asset that Ripple created? How is it different from Bitcoin? Abraham is going to cover a little bit about HBase infrastructure that we use, and then a quick demo, and then maybe some time for some questions. So what is Ripple? Who actually has heard of Ripple? Fair amount. It's pretty good. So our vision is to essentially create the internet of value. And what that basically means is to enable the world to move money like information moves today. So if anyone sent a cross-border payment, knows how hard it is to get from one location to another. And we think that's just not right for the times that we're built. We think money should move faster, but we should also not compromise the actual forensics and analysis that need to be put in place to make that money move faster. So our mission is to make cross-border payments truly efficient for banks and their customers. Now I'm just going to go over real quick the difference between, now who here has heard of Bitcoin? Okay, glad your heads have not been in the sand. So actually, just some kind of go over this, but Bitcoin was essentially created 8 years ago. The actual idea behind the Ripple Consensus Ledger, which is the root ledger for XRP, the digital asset, was actually formulated well over 10 years ago. There was an idea that someone could create a system that could transfer value based on credit. It was a credit-based system. And this was actually the first implementation of that. And there are some pretty distinct differences. So just how I said in April, the data is a little different. From April until present, the actual market cap of Bitcoin doubled, and the market cap of XRP actually went up 5 times. So the XRP market cap right now is about $25 billion. And with Ripple actually owns 60% of the XRP in the market. So it's kind of put us in a really good position to be able to continue building out the technology and make sure that we're enabling a protocol for future payments. So another difference between Bitcoin and XRP is Bitcoin's inflationary. So the supply is actually increasing. Now there is a fixed supply. Someday the last Bitcoin will be mined, but that's over 100 years from now. Where actually XRP is actually destroyed on every transaction to reduce spam on the network. And so you can actually see there's a counter on our charts page that actually shows how much XRP is in circulation. So a critical difference is how transactions get validated. So in Bitcoin, they're validated proof of work, where you've heard of a Bitcoin mining rig. It's a very computationally intensive process. So it has required a kind of a centralization of sort to whoever has the access to the cheapest amount of power, where the Ripple Consensus Ledger is actually validated by a more classic consensus. And it requires a subset of the network to essentially, be the network that's validating the transactions. And as long as you trust that network not to collude, then you actually have a pretty good secure model. So the confirmation time in Bitcoin, it actually is 10 minutes, but it requires, they say, 3 to 6 confirmations. And the reason is because, the problem of double spending, Bitcoin was one of the first to actually solve the problem, but actually requires, maintaining a history of these blocks that every transaction has to basically go back, to the Genesis block to ensure that there's no double spend. In XRP, it's confirmation by last ledger closed, and a new ledger is closed actually every 3 to 5 seconds. So we actually don't have to maintain a full history of the transactions in order to have a true finality of settlement. What that basically means is when I send money from A to B, that recipient actually has the money, and there's no way that anyone can take that back. So there's actually no scripting in Bitcoin. There's process for automated scripting in RCL. Bitcoin is pretty much single purpose. There's no decentralized exchange or any other kind of elements in the Bitcoin blockchain. Ripple Consensus Ledger actually does have a decentralized exchange. So we, design the infrastructure so that, you can actually share the cost of running an exchange, because it's, pretty intense for anyone to build an exchange from the ground up, where there's actually a decentralized exchange embedded into the architecture. The similarities are that, both systems do use hash tree data structures. So on that note, I will give it to Abraham.
So, as with most financial institutions, reporting becomes a very key feature, making sure that what accounts have what balances, what transactions have transpired, reconciliation for these various organizations, as well as the big thing of compliance. So my goal was to enable real-time transaction visualization. So we support a site called XRPCharts.ripple.com. Used to just be called RippleCharts. I'm still getting used to it, but our marketing team decided to rebrand it recently. And that charts is a site is a real-time visualization of all the data that's on the Ripple Consensus Ledger. It required me to really think about what's a good system and fast system, something that's pretty consistent and robust and scalable through time. Obviously, we're all here because of those similar reasons. HBase gives us that core foundation where data is guaranteed consistent. It also gives me the benefit of having a Hadoop cluster as a backbone and a simple data warehouse for internal reporting, which I've also done. This is a very familiar stack. I'm sure you've seen it, where data is basically pulled into a Kafka queue. We have a Storm infrastructure framework to process data, gets ingested into HBase, and then gets spit out in varying ways. Most of our technology that goes back out to RippleCharts is nodeJS. So we are, I'm getting a lot of good looks here. Yes, we are using nodeJS to place and retrieve data from HBase. I am planning to make changes to some other stacks and languages, but it seems to be working at this point in time. We are making slow improvements. Typical pipeline, you guys seen this, where data just gets pushed in and moved out. More interesting is how much we actually serve. This is a very small cluster. It's a 5-node HBase cluster. I have actually a backup cluster, which goes to a 3-node cluster, and I have active replication. They're cross-country. This serves the entire world currently. And right now, I can handle about concurrently 1 million operations a second. Not bad. I haven't really implemented anything really extensive or heavy, such as coprocessors or massive structures, because I took the time to design the tables based on the queries that our existing chart system does. Very key oriented, very specific, and very explicit. Yes, that does lead to data replication to a certain extent, but at the time it was simpler and cheaper to just do it that way. So yes, purpose-built tables built on known query patterns. They are very specific. So once you go to RippleCharts, you'll see an exchange page that queries one table. If you go to a payments chart, it goes to a payments table, all key-driven and very intentionally designed. Data, one single ledger can hold over 1,000 transactions. Our largest transaction set was, I think, at need close to 2,000 entries, 2,000 transactions on a single ledger. So it creates a very unique design infrastructure when you actually have to design the tables into a certain way to match the queries that you're trying to get. But again, I was trying to design to serve the need of charts, and data consistency was the first and foremost thing in my mind. Let's see now. I'm going to try and demo something like most. Hopefully this works. Come on. Of course not. Like most good things, demos don't work. Okay, fine.
Has anyone gotten it to work before?
I don't think so. Everything is pretty much static. So I'm going to try my best. So this is our site, RippleCharts.
No, you're off.
Oh, God. That one? Oh, sorry. Hey, did I really screw up?
Which one are you trying to present from?
I don't, this one primarily if possible,
Well, this one will work.
but this one will work for now. Now it's only a camera. I do apologize if I broke it.
Can this detect external displays?
I'm funny. Yeah. Oh, you're in mirror mode. Do I have to re-enable mirror mode? Whatever that is.
It's a mirror.
Does anybody have any questions while we're?
Just like good demos.
How does a ledger correlate with writes?
Sorry. You first.
So how does a ledger correlate to writes?
Rights.
As
Like,
in,
what are your transactions?
so a single ledger that can carry multiple transactions. The transactions can be a payment, settings on an account, offers for an exchange, and actual close of the exchange. So if I wanted to trade accounts from send payment from me to him, that is a one transaction. If that included me exchange, I only carry RMB, Chinese yuan, and he needed euros, and none of us have either to exchange, but you carry both. I can bounce to you, change it for that, and you would send the funds to him.
Yeah, we actually on an average day we process 3 times the amount of transactions per day as a Bitcoin blockchain. So it's the system is scaled pretty well.
How much is
The fee.
No, the volume, number of transactions per second.
volume?
So they have a theoretical threshold of processing approximately 8 transactions per second. We did a benchmark test across a global distribution of servers, and we scaled up to just about 1,000 transactions per second. So it's to kind of give an example. Visa is kind of the number one, and they have a theoretical transaction throughput of about 50,000 transactions per second. But even on the busiest day of the year, Black Friday, it's usually only about half that or less than half that. PayPal, for instance, processes just about 200 transactions per second. So 1,000 transactions per second gets us a long way. We released a feature that allows an off-ledger system to actually scale up to tens of thousands of transactions per second if that's actually required. So we do have a lot of room for scalability. Any other questions? Everything's open source actually. So if it's XRP related, it's open source. So we it was open source initially created 4 years ago, and we have a team of 12 full-time developers working on the actual protocol.
Ripple D, as well as the XRP charts, the visualization that I'm trying to demo, as well as our ETL process are all available on open source. Just go to GitHub Ripple and you'll find it there.
As a consumer, if you're into risky speculative investments, I will not advise you to, look into getting into that. The way we look at it is that
so sorry.
XRP specifically will, at least in the initial phases, be a bridge currency for basically B2B transactions where the actual consumer won't even know that a transaction is actually taking place in XRP because you just see US dollars going to, some other country very fast and very cheap, whereas that's actually bridging through XRP. So we kind of see XRP becoming, a new world global currency for bridging cross-border payments.
So this is a replacement for SWIFT, basically.
So we've actually we have a proprietary software that's actually built on top of both of our open source technologies. That is a direct competitor, Swift, but Swift actually only does the messaging component. We've actually built the messaging and then the actual settlement component as well.
So it's similar to ACH.
Cool.
Yeah. So. But globally, right. But we can actually do it in real time. So we've actually been doing test payments where you can actually test, a US dollar payment to Mexico in a matter of seconds, or a US dollar payment to India in a matter of seconds. So these actually, this is our kind of gearing toward our future of a vision of making money, move like information moves today.
So this is our landing page of XRP charts. This is the number of coins that are being slowly decremented. Wow, this is very choppy. So I'm going to go as slow as possible. This is in real time. It's ticking in real time. What I can do, oops.
Is every single data point going through HBase?
Every single data that's on the ledger that is also going on HBase. So this is our stream process of all the transactions as it streams through. And if I click on one of them, this will tell you exactly what details inside the transaction. Instead of reading it like like our core engineers who can actually read the actual meta information in binary form raw, I have to suffer with translation libraries. But the translation library, as you can see, it runs pretty fast. So it tells you that this particular offer was created, who the addresses are for going to back and forth, and what the effective points are on the node. Varying markets, you can actually pick, let's say, US Bitcoin to USD. Let's choose XRP. And that's our current live chart, plus our current live order book, what's available for exchange and bids and asks. So we're of a mix of Bloomberg and as well as a banking payment transaction software company. This particular is our charts system is completely open source and it's for external consumption. We have internal tools that does even more. Let's see now. These are transaction metrics, how many transactions we've been processing, ledger throughput. No, not at this time. This is pure HBase, and we have about 40 tables that we disperse the data in replicate form just for these varying queries. So this is a map of our Ripple network topology. That's not rendering.
Yeah, and the front end for this is actually D3JS, so it's actually been a lot of fun to work with that.
Probably try and finish up, right?
Yep.
Yep.
I think we're all done.
Any questions?
You can do, maybe do that last one.
Yeah.
We're all supposed to go back together.
Okay. Look,
All right. Thanks a lot.
thank you. Thank you very much. I do apologize.